Okay, so far we have checked the variables such as edu and GDP as dependent variable. So now our last variable is investment, right? Last variable is investment, and we want to check it what happens to this variable. Okay, and that means this one, the last variable. So far we have checked this one, we have checked already. This one we have checked already. Now I am checking the last model, right? And where INV is the dependent variable. So I copy it. I copy as before, and I go to proc quick as before. Then I estimate the model as before. Then here I paste the model. So here is the model, you can see, and the INV is the dependent variable. Then I press OK. So this is my last model. You can see this is my model, right? Okay, and here this one is the dependent variable. Okay, now I want to check. Okay, I'm checking. So first I check this one, whether the edu can influence INV or not. So what does it mean? What is edu? Edu means, what is our null hypothesis? C15 equal to C16 is 0 or not. That is our null hypothesis. You can see C15 and C16s. So they are jointly 0 or not. So, and here we shall use the wall statistics as before. Wall statistics as before. And make sure these coefficient actually all are short run coefficient, not long run coefficient. This, right? All are short run coefficient. Okay. So I go to view, then go to coefficient, then I go to wall test as before. Then I set C15 equal to C16 equal to 0, right? So that is our null hypothesis, right? That means C15 and C16 are 0 or not, right? So I press OK. It is wall test, null hypothesis, C15, C16 is 0, and chi-square, what is the chi-square value? 0.68.27. So meaning that how much is the p-value? 68.27%. 68.27%, which is more than 5%, meaning that we cannot reject null hypothesis, meaning that C15 and C16 they are jointly 0, meaning that there is no short run causality running from edu to investment. So that is the decision. There is no short run causality running from education to investment. So that means if the C15 and C16 0, meaning that there is no short run causality running from edu to INV. Okay, then what about the second model? Second thing, GDP, that is C17 and C18, whether the GDP can affect INV or not. So that we can check C17. So we set our hypothesis C17 equal to C18, sorry, C17, C18. So they are 0 or not, right? They are 0 or not. So I go to view as before, then coefficient diagnostic, then wall test, right? Then I put the hypothesis C17 equal to C18. Are they 0 or not, right? So that is our hypothesis. I said it. Okay, and wall test, and it is the hypothesis C17, C18, 0, chi-square, and the probability value is how much here? The p-value is actually 0.79%, and which is less than 5%. So we can reject the null hypothesis. That means C17 and C18 are not jointly 0. Meaning that, so what is the meaning of it? The meaning of it that there is a short-run causality running from GDP to INV. Because C17 and C18 are not 0, meaning that there is a short-run causality running from GDP to INV. So that is the decision of this model. Then finally, how is this model? How is this model? How is this model from the statistical point of view? Okay, so I can check. R squared is quite small. R squared is only 50.99%. It is quite small, but the F statistics is significant. You can see from here it is less than 5%. So we are happy about it because F statistics is significant. Okay, then I check view, the residual matters. So first I check serial correlation, right? Okay, serial correlations. Okay, I check serial correlation. So it is the observed R square, and how much is the p-value? P-value is here is p is 32.96%, and which is more than 5%. So we cannot reject null hypothesis, meaning that there is no serial correlation in this model. So we are happy about this model because there is no serial correlation. Okay, then we check again. I go to view, residual matters. Then I go to this one, test of heteroscedasticity, and here I press OK. Okay, this is the test, and this observed R square. And how much is the p-value? P-value is the 54.13%, which is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is no heteroscedasticity in this model, and that is desirable. We are happy about the model because there is no heteroscedasticity. Finally, we check the test of normality. That is the test we can check. Okay, so it is the Jarkabera statistics and corresponding p-value. How much is the p-value? P-value is less than 5%, right? Less than 5%. Less than 5%. You can see from here, less than 5%. So meaning that the residuals are not normally distributed. Meaning that residuals are not normally distributed. So we are not happy about these models because residuals are not normally distributed. So that is the end of our discussion end of our discussion regarding short run causality. Okay. Cheers. Good luck. Bye.